Multiple linear regression models the relationship between a continuous dependent variable y and multiple independent variables x1, x2, and so on. So the difference of multiple linear regression from that of simple linear regression is that now we have multiple variables as our covariates or exposures. So this allows for the adjustment of confounders and covariates, and that helps in isolating the true effect of the primary exposure variable on the outcome. For example, if we want to know how cholesterol is associated with, say, systolic blood pressure, we can now have age and gender and smoking status, all of them in the same model, and then we can have the true effect of cholesterol on systolic blood pressure, because this model will help adjust for all the other variables. So we will have now be comparing the apples to apples, meaning that the person with the same cholesterol level, of the same age, same gender, and even the smoking status being the same, how this person compares with another person by just differing on cholesterol status when it comes to the systolic blood pressure. Mathematically, now we have multiple variables. So compared to simple linear regression, when we have only one intercept and one slope and one exposure or predictor, now we have multiple. So all of the effects will be added mathematically. Over here, beta 2 might be the slope of the second variable or confounder. X2 is 1 unit increase or decrease of that that additional confounder, and so on. And when it comes to categorical variables, say with 3 categories, what happens is that mathematically the statistical package is going to compare each of these categories to one reference category. For example, if we have, say, 3 categories: normal cholesterol level, optimal cholesterol level, and high cholesterol level, and the system might assign optimal cholesterol level to the reference value, and then compares the other 2 categories with that one reference value. But in case of continuous, it will only provide 1 unit increase. It will provide the slope for the 1 unit increase in that continuous variable. Rest of the interpretations remain the same as were in the case of simple linear regression. For example, in case of predicting systolic blood pressure using multiple exposures like BMI, age, and sex, now the equation would look like something like this. Systolic blood pressure is equal to beta naught, which would be the theoretical intercept when all the other values are 0. So the systolic blood pressure at the starting point. First is the slope for BMI. With each unit increase in BMI, how much is the increase in systolic blood pressure? Now here, because we have again the age is mostly measured in years, so the slope will measure the increase in systolic blood pressure with each 1 year increase in age. But in case of sex, we have 2 categories, male and female. So the slope will assign either male or female as the reference level, and then we'll measure the slope for the other sex. Maybe say if the male was the reference, then it will give us the systolic blood pressure for the females compared to that of males. Maybe say 2 millimeters of mercury lower than the males for males systolic blood pressure. When we were conducting simple linear regression, the relationship was represented by a line in two-dimensional space. In multiple linear regression with two predictors, the relationship is visualized as a plane in three-dimensional space, as you see on your screen. A flat plane indicates no relationship, but a tilted or a sloped plane indicates there is an association. With three or more predictors, the model exists in a higher dimensional space and is no longer visualizable. However, the mathematical principles will remain the same. For hypothesis testing in multiple regression, the null hypothesis would be that all predictors have no effect, meaning that slope for the predictor 1, beta 1, is equal to the slope for beta 2, that is the slope for the predictor 2 is equal to the slope for the third predictor beta 3, and all of them are equal to 0, meaning that there is a flat plane. An alternative hypothesis is that at least one predictor significantly affects the outcome. So one of the slope is not equal to 0.